This is a short video on how to graph parabolas. And we're going to look at the very specific case of parabolas generated by equations such as this, where a can be any non-zero number. And it can be a lot more complicated than this, but this is a pretty good place to start. And furthermore, my students are using an online textbook that packages the material in this way. So let's get started. First, we're going to look at an equation of this form where the a is just the number 1. Now, more often than not, people will write this as just y equals x squared. They will omit the 1 because the 1 is just multiplying and it has no mathematical effect. You can generate a table using this equation in the following way. When x is 0, take 0 and square it, or multiply it 0 times 0 if you prefer, and you'll get 0 for an answer. Now you have an xy pair that you can graph. Take x equals 1 and square it, which could look like this, 1 times 1, and you'll get 1. There's a pair, 1, 1, and that is located right there. Okay, one more example. Let's skip down to x equals 3. You can do 3 times 3, or you can do 3 squared. Either way, you're going to get 9. That's where this 9 comes from, and the pair 3, 9 is seen on the graph up here. Now, this is not a line. This is a curve. This curve has a name. It's called a parabola. And if you're not used to graphing curves, then, well, I think you'll enjoy this. There's a lot of vocabulary associated with this, but before we get to that, notice that this curve that has a multiplication of 1 here, y equals 1x squared, it seems to open up, and that is from its lowest point, both to the right and to the left, the graph appears to go up. Contrast that with this one. This is y equals negative x squared, which could be written negative 1x squared. So I'm looking at the case of a equals negative 1 here, whereas I was looking at the case of y equals positive 1x squared here. Big difference, isn't there? First of all the entries in the table are not positive. They're either 0 or negative. And that's because all the calculations that we did over here would be followed by the multiplication with negative 1. So for example, to get this 9, I did 3 times 3, or 3 squared. If I then multiplied by negative 1 instead of 9, I'd get negative 9. And with this exception, all the y values in this table are negative. And this parabola would, from the origin here, would be described as opening down. So whether we go to the right away from the origin or whether we go to the left away from the origin, the parabola seems to be traveling down. Now, some of that vocabulary I promised we'd talk about. First of all, every parabola has a vertex, and for both of these two examples, the vertex is the same. For the first parabola, it's this lowest point, the turnaround point, where the parabola changes from decreasing to increasing, moving left to right. On this parabola, the vertex is here. It's the highest point. It's the place where you get a maximum y value. It's a transition from where the graph goes from increasing to decreasing as we move left to right. So in both cases, the origin is the vertex. In other cases, other parabolas that we'll look at, the vertex may be something else. But it's always either the highest point or the lowest point. Both of these two parabolas have a symmetry axis, and it is x equals 0, which of course is the equation for the y-axis. The reason we might call that a symmetry axis is every point over here, such as 3, 9, is mirrored by a point on the other side of the y-axis, negative 3, 9. So this is 3 to the right, and this is 3 to the left, and they look like reflections of one another. In fact, this whole right half of this curve appears to be reflected over to this side. The symmetry line, x equals 0, or the y-axis. And the same comments apply to this curve. Other parabolas have some other symmetry line, and I'm sure we'll see some examples of that today. Well, y is increasing in the table 0, 1, 4, 9, 16, 25. Y is increasing for this first example as long as x is greater than or equal to 0. So y is increasing on this half of the parabola. But if we move from left to right, as our x's increase, on this side of the parabola, the y's are decreasing. So y's are decreasing if x is less than or equal to 0. We already mentioned that this opens upwardly. You can just write up. This one opens downwardly. You can just write down. Let's talk about this curve. Where's y increasing? Y is increasing as x moves from left to right. Y is increasing over here from -9 to -4 to -1 up to 0. That's this part of the curve. So y is increasing when x is less than or equal to 0. But if we go to where x is positive, greater than or equal to 0, y is decreasing. And you can see that as the curve falls. And you can see that in these numbers, 0, -1, -4, -9. So y is decreasing on this particular graph where x is greater than or equal to 0. Finally, domain. Domain is the type of x's that you are allowed to put into this table. There are no restrictions. I could put negatives, positives, big numbers, very, very negative numbers, fractions, decimals. You can put anything you want into this equation, and you will generate a point that's on this curve. So most people will write all real numbers for the domain. I've also seen it written like this: negative infinity is less than x is less than infinity. That's basically just saying all the way across the x number line, you will find x's that are found on this curve. Now, the range is something different. Range asks, well, what kind of y's do you get to see? A quick glance at the table suggests that in this problem, you cannot get y's that are negative. And it's true. That's why this curve is always above the x-axis, or perhaps touching it right there. So the range for this one is y is greater than or equal to 0, and the range for this one is y is less than or equal to 0. Now, could you graph one of these things without a calculator or without tables? We're going to get a chance right here. And you just saw what these graphs look like, but I want to give you the fastest way I've ever discovered to generate one of these graphs on your own. Once you are certain of where the vertex is, then you want to follow something I like to call the 1, 3, 5, 7 rule. And this, of course, is just a sequence of odd numbers. And after 7, if you had space, you'd go with 9 and 11 and so forth. But these are for this first graph, y equals x squared, or 1x squared, these are the y increases as x moves to the right. 1 unit. So if x moves 1 to the right, y moves 1 up. You might put a check mark there, because the next time we move 1 to the right, you're not going to move 1 up, you're going to move 3 up. And that's not from here, that's from the level that you're at right now. So that's 1, 2, 3 up. The next time we move 1 to the right, we're going to go up 5. 1, 2, 3, 4, 5, somewhere up in here. And now if you want, you can repeat this by going to the left. Left 1, up 1. Left 1, up 3. Left 1, up 5. And then do your best job to sketch a curve through here, which at the bottom should not be sharp like a chisel. It should be rounded off like this. And then for y equals negative x squared, I would make very, very similar comments. Start at the origin. But remember how this one decreases whether we go to the right or the left? So go 1 right, 1 down. 1 right, 3 down. 1 right, 5 down, which is down in here somewhere. And then you can do the same thing on this side. Or you can use the symmetry line and just reflect these points over. So you have a point that's 1 away from the symmetry line, the y-axis. Put a point 1 to the left. Here's a point that's 2 to the right. Put a point that's 2 to the left. It's a little hard to see, but this point is 3 to the right, and you can just put a point 3 to the left. So that's an example of using the symmetry line to quickly locate some new points. And then again, draw kind of a nice smooth curve here. I should be better at this than I am, but I think this will be good enough for today. Now, the remaining problems that we're going to discuss today are found on an online assignment that I gave to my students. Oh no, we have two more quick examples first. How to get y equals 2x squared. How to graph y equals negative 0.5x squared. And how to do this without a computer or a table. All right, so unless you have a 1 or a negative 1, you cannot use the 1357 trick, but you can modify it. So you could take 1357, and if a is equal to 2, multiply all these by 2. So 1 times 2 is 2, 3 times 2 is 6, 5 times 2 is 10, 7 times 2 is 14. And now we get a sequence of even numbers spaced by 4. And this is what we're going to use to climb up and away from the origin. Well, now how do we know we're going up? How do we know that this parabola opens up? And the answer is A is positive. So go 1 right, 2 up. Then go 1 right and go 6 up. Well, we're going up so rapidly, we're going to run right off the graph. And we're not going to be able to do very many of these. That's all right. We'll do it on the other side. 1 left, 2 up, 1 left, 6 up, and then draw the curve. And again, do your best to make the vertex down here, make the parabola look rounded a little bit there, because it is. Don't make it sharp like a chisel. Now, some would say that this parabola, compared to the one we drew previously, which looked like this, some people would say that this has a vertically stretched look to it. It's taller, it's narrower. Some people call it vertical expansion. Our online textbook calls this vertical stretching. You're going to see the opposite over here because we have a number here that's closer to 0 than 1 is. It's 0.5. It's actually negative 0.5. But that tells me two things. One, this parabola will be inverted. It'll open down on both sides. And two, rather than being a vertical stretch of this, the parabola I'm going to get will look like this has been, the word our book uses, well, I use the word compressed. So it looks wider, it looks like it's reluctant to go down. It's going to look something more like that. I think our textbook calls it vertical shrinking. So there's, I suppose, different ways we can refer to it. But how do we use the 1357 sequence? We don't unless we first modify it. You're going to multiply everything in this list by negative 0.5. So 1 times negative 0.5 is negative 0.5, or a half. 3 times negative 0.5 is negative 1.5. Get a calculator to help you if you need it. 5 times negative 0.5 is negative 2.5. And finally, 7 times negative 0.5 is negative 3.5. And this is a sequence that helps me drop down from the vertex. So 1 right, only down 1/2 of a unit. Now go another 1 unit right, but this time go 1.5 down. Go 1 to the right again, and we're up to using 2.5 for our drop. And then the next time would be 1 to the right and down 3.5. And you can mirror those points over here, like this. Or you can use these drops again. This drop, I believe, was 2.5. So 1 left, 2.5 down. 1 left, 3.5 down. And you can see we get a very different look than we did when we graphed y equals negative 1x squared on the previous page. Okay, So yes, from this point forward, these are just problems right off the worksheets that my students will be doing today. And there's a lot of vocabulary here. And so they give you a graph, and it's a parabola, and they want you to tell where the vertex is. Well, it looks to me like it's -1, 2. No, it's not. You have to read carefully. This is -4, so this must be -2. And then this is clearly 4 because I see the 4 right there. The vertex is -2, 4. And I think they wanted you to spread that across 2 boxes, but there it is. The axis of symmetry is over here, and that's at x equals -2. The domain is, okay, this is going to be the same all day long. It's all real numbers. The range is, well, the lowest y number you're going to get is 4. I can see that from the graph. So you can get numbers like 4 and 5 and 6 and 7 and 8. The range is y is greater than or equal to 4. Now, when x is less than -2, so we're talking about from here left, y increases as x decreases. I don't like that very much, but it is not wrong to say that if the x's are decreasing, then the y's are increasing. Now, when you get to the right of -2, y increases as x also increases. So when we're right of -2, the x's go -2, -1, 0, 1, 2, 3, 4. They're increasing, but the y's are increasing also. We have 4, 5, 6, 7, 8, 9. And so in that case, y's and x's are increasing together. That was an interesting problem. Let's keep this moving here. Here's an example. We have a graph, -2x squared, and we're trying to compare that to the graph of x squared. Now, we've done both of these today. The graph of -2x squared is inverted like one of these, but you would expect also that it's got a vertex at the origin and that it follows the pattern of not 1, 3, 5, 7, but a minute ago you watched me multiply all these by -2 and get -2, -6, -10, -14. So we're looking for something that as x increases by 1, y drops by 2, and then by 6. I think I see it right here. 1 to the right, 2 down. 1 to the right, 6 down. So I'm going to check that one. But you might want to take a more careful look. Now, how does this graph compare to y equals x squared? Well, remember we graphed y equals x squared back on that first page, and it looked like this. And so compared to that, the graph of this new function they're calling m is it's a vertical stretch is the word they want you to use here. Vertical stretch. By a factor of -2. And it's also a reflection in the x-axis. So this one goes here. Of the graph of f. In other words, here's y equals x squared. A reflection in the x-axis would look something like this, where you take the whole curve. Yes, this is just a shoelace. And you flip it over the x-axis like that. That's a reflection in the x-axis. All right. New example. Use a graphing calculator and graph y equals 4x squared and then compare it to y equals -4x squared. I wonder if we can do this without even looking at it. They both say times 4. No, this one says times -4. So we know this one's going to open up, and we know this one's going to open down. But you can go to Desmos and check that. You'll get these two graphs for 4x squared, it'll be very narrow, and it'll be upward opening like this. And for negative 4x squared, it'll also be very narrow, and it'll be downward opening like this. This is a reflection of that in the x-axis. So put this here. And that is going to conclude our video today. Hope you enjoyed this. My name's Eric. Have a good day.